Hey everybody, I am back with part 3 of this printer build. I'm trying to keep the printer here in the frame, so excuse me if it's not the best framing for the whole stream. Appreciate VJB and Robert joining me in the chat. And I think this time I've got it all laid out so that we can finish up the mechanical construction of this printer. I am going to hopefully get the vertical rails put up first, then we'll get our X-axis done. And let me see, I hear myself through one of these speakers, so I don't want that to happen. Let me turn this off real quick. Alright. Anyway, so kind of jumped the gun there. So if you're new here, I'm Chris. This is Kersey Fabrications. It's my channel where I basically try to show off what I've been working on. And so this is my first big project. I'm working on a large format printer for Cosplay. I've called it the Cosplay 600 because it's just a little bit over 600 millimeters wide. It's a standard i3 design, but I've bulked it up a bit with some 4040 extrusions that I've built for the verticals. And I've currently got a ball screw on the y-axis, which is providing a lot of torque for the movement there, as opposed to the normal belts that are used. So I've been doing some experimenting with this ball screw. I'm a little concerned that it might be a little slow for 3D printing. If that's the case, I'll either have to come up with a better solution than the stepper motors that are usually used. I think that I could go with some servo motors possibly. They're a little bit more expensive, but they have a higher speed to them. But if I don't do that, this plate that I've made to begin with, I actually built in 2 places to put belt mounts. So what I would do is actually do dual motors on my y-axis for the belt movement. So I don't know exactly where that's going to go. I'm going to do some tests once I get everything put together, and we'll see. Hey 3D Print Viking, welcome back. Good to see you again. So if you have any questions, I've got my phone up to the chat, and I am going to do my very best to respond to any questions that you have during the stream. If you see me off screen like I am now a little bit, I'm just checking my system, making sure everything is streaming correctly. So we got 7 people joining us. If you haven't noticed, I'm playing a little bit with the time slots. I've tried weekends. We did a holiday. Now I'm doing a late evening stream, at least late evening for me, and just trying to see what time slots work best for people. So let me get up my. So in the upper, should be the upper right hand corner for you guys. You'll notice I've got the model of the printer. What we're going to start with today is we're going to be starting with this component down here. You notice I'm missing the screws, and that was just because I couldn't find a good model, the right length of the lead screw that I'm using for the Z-axis. And last stream I actually had these parts. Here, let me zoom in so you can see them well. I actually had these parts that were 3D printed, already assembled. But obviously I can't actually put on the vertical rails, the vertical rods, if those are on. So I've taken those back off to start this stream today. Like I said, I think I've gotten all of my components laid out today, got all the screws ready. Oh, 2 a.m. in Norway. Well, I appreciate you staying up with me. Yeah, I realized that doing the later stream was going to be a problem for the European viewers. But again, we're just started playing with these. I've done afternoon streams as well, so which isn't the best for the West Coast because that means they could be morning or early afternoon, so depending on what day of the week it is. So let's get started. I don't want to waste the whole stream just talking about it. I can talk while I work. So if you've noticed, I've actually turned the printer around today, and because I'm going to be working mainly on this side, so I wanted to turn it around. The motor's back here this time. This is the front of the ball screw. If you notice, I've got a lot of components here that are different colors. They've been printed in different filaments, and that just because most of these components, these are the first or second time I've printed them, and so these are just prototypes. What I consider, anytime I print something for the first time that I've designed, I consider the first one usually a prototype, because there's going to be some small change I have to make. And so with these, I am planning on, if everything works together, if I like the model, if there's no changes that have to be made, I actually plan on reprinting all of these in a common filament to make them all look the same and to make them as rigid as I'm looking for them to be. So we're going to start out. Let's get these mounted, and then we'll get the motors mounted in them. So again, we're using the type of nuts that actually you can put in the slots in any direction, and then they tighten, they twist and tighten into the slot like they're supposed to. So I'm going to have to play with how it works best. I think I'm going to be behind part of my screen here, but again, let's just work on getting everything done today. I've got the stream scheduled for 2 hours. Hopefully you can hear me, because I'm not near the mic at the moment, but it's a pretty good mic. I've got the stream scheduled for 2 hours. If I'm close to being finished and I'm not quite done yet, then I will go over a bit. If I get done early, we'll either chat or we'll take off early, one or the other. So excuse the sniffing. It is winter here in the US, depending on where you are, and there's plenty of colds and such going around. So what I'm working on right now is just getting these tight. Sometimes these type of nuts actually have to be messed with a little bit, otherwise they won't latch on the way they're supposed to. So I have to make sure that I can feel or actually see down the slot that they've slotted into place like they're supposed to. Thanks. Also, let me know if the sound is in sync. I took a look at my last 2 streams, and I noticed that since I'm using a different audio and video source, and the video source has a slight delay to it, that I was running into a time sync problem. So one thing I'm noticing on these is that it looks like I might have the they may not be tight enough, which means that there's not enough plastic to sink these down. So what I need to do real quick is back them out and either put a nut on them or put shorter screws. I'm not 100% sure I have shorter screws, but I know I've got some M5 nuts that I can put here. If you're new to this project, this is your first time tuning into the stream or to my channel in general, what I'm doing here is building the first prototype of this printer. Haven't built this one before. So let me see if I have my screw boxes here. I actually don't know if these M5 washers may be too big. Let's take a look. One way or another, we'll figure this out. I kind of enjoy the live stream format because you guys get to see the process of engineering something like this from the start, and some of the potential problems that you run into that you didn't plan on. So what I'm going to do, these standard, I think 10mm screws that I normally use are a little bit too long. So I've got some 8mm ones that will probably fix the problem. So I got plenty of these 8mm ones after all. I was a little unsure if I did, but it looks like I'm fine. So we'll switch to some 8mm screws. Again, we got 12 people watching the channel. If you're new here, if you enjoyed the stream, please subscribe. Got a lot more videos coming. I don't know when my next live stream will be. This will be... I'm planning on this being the last live stream of this series. From here, I'm going to do all the electronics work in my own time, mainly because I don't think soldering and plugging in connectors and modifying source code is actually all that interesting for a live stream. So, not to mention the number of problems that can arise is probably not conducive to getting anything done. But there will be obviously follow-up videos once I get everything working. I may live stream, you know, one of my first prints or something, just to give you guys a little bit of, hey, look, it's working. If please join in the chat. If you know, if you have any questions about what I'm doing, comments, concerns, this is working. These are getting tight now. So. There we go. That's better. Not sure if they all got down all the way. Let's see if that's it. I don't want any wiggle in these brackets. Otherwise there's going to be a problem. Okay. There's a little wiggle in them. I think it might be in the model. I don't think it's going to cause me problems at this point. And like I said, if I need to reprint this later and just replace the part, that's not a big deal. These printers are pretty modular, so let's go with that for now. Let's see. Alright, next side here. And let's go ahead and take out these 10mm ones I had prepped. And we'll put some 8mm ones on here. So, what's everybody else been working on? If you're watching, you've been working on a 3D printer that you just got, or if you worked on a print that you're particularly proud of, please feel free to chat about it or talk about it in the chat room. I appreciate you guys coming back that have been here for other streams. This is not the best angle for my back, but it probably is a pretty good angle for you guys. I might have to go around the table for this one. Let me see. Sorry, I'm not exactly, I might have my head in the way a little bit here, but it's the only way I can get to this screw correctly. So when I'm mounting these bottom brackets, to make sure that they are lined up with both sides, I am pushing it all the way against the bracket that's holding the uprights up. It's just to make sure that everything's all lined up. Okay. So this one doesn't have the wiggle that the other side does. I'm not exactly sure. There might be a small, maybe there's a little wiggle in there. I think I'm going to have to beef up the screw holes. The screw holes that are mounting this to here, they probably need to be a little bit thicker. That'll keep it tightened down. No, I will not be at Murph. I'm nowhere near Murph. Next year I would like to be, I guess we're calling it IRF. The East Coast one is possible, but we'll have to see kind of how the YouTube channel does between now and then, and what's going on with my family during that time of the year. Tried to make it there this year, but there was other stuff going on. Alright, so we've got these mounted now. Now I've got two of my stepper motors. Now these stepper motors I'm using, I don't know how much it matters to you, but they are 17HS 4401s. These have pretty good torque to them. I've used them before on another printer that I was working on. I've actually got the screws in here already, so I'm just going to pull them up a little bit. Let's see, what you doing, 3D Viking? Yep. This is going to have a V6 hot end on it. In fact, depending on what happens with the speed of this printer, I may end up putting a Volcano on it as well. To really be able to get some speed out of it. But if you can't tell by some of my design choices, the speed is secondary on this printer to the quality of the prints to me. I'm not looking to pump out a lot of production parts or anything like that. This is not a commercial printer for me. This is, as it's labeled, it's a cosplay printer. And the cleaner and nicer I can get the print, the less post-processing I have to do. So speed is not the top concern. This is a new screwdriver set I just picked up off of Amazon. I'm still trying to figure out what all the attachments, what kind of feels the most comfortable working with. Where did I stick? Okay, so I've got my power connector going out the side here. I think that'll work best for the orientation. It's going in a little tight. Probably just the angle. I'll make sure I got it. Let's see. Thought about actually preloading these motors into these mounts, and then I realized if I did that I couldn't mount them to the extrusions, because the extrusion mounts are underneath the motor. You have to mount them first. So, well, as I was mentioning, while this is a large printer, I'm not nearly as concerned about how fast I get the prints off. This is not the easiest location to tighten, being up against this extrusion. It's actually not going in quite as smooth as I wish it was. I'm not sure if it's the screw or if I don't have it lined up quite as well as I'd like, so I'm going to back it out a little bit. I don't like to mis-thread screws, especially on something like a motor, because you'll never get that thread back. So, looks like there actually may be something on here. So, let me grab another screw. Pretty sure these are 12s, yeah. It's a 12mm screw. Obviously, if I was going for speed, I would have had to gone with a different design, I think. Okay. That's good and tight. I'm not 100% happy with that mount, so I'll probably reprint it. So if you're a subscriber to the channel, I have another video that'll probably be out Monday It's all ready to go. I've been working on it for the past week. It's a video kind of showing my process of working on these extrusions, how to cut them, how to drill them, and how I made these 4040 uprights. So when I was building this printer and looking for parts, at the time I could only find one company that had these 4040 extrusions with the dual profile, the dual slots in them, and they were really expensive. They were like 4 times the cost of the 2040s. So what I decided to do, rather than paying the cost, is I was just going to take and figure out how to assemble these myself. So these uprights, if you can't tell, are actually 2 2040s, and they've been screwed together, cut down to the same length. And so that video that I've got coming up in the next couple of days is actually shows the process of assembling the two together. You can't see it in this video. You'll see in my other one. I've got 2 screws here and 2 screws here, really bolting these together, and it's really, really secure. Let's see. So let's keep going. So these are in here now. The next part is, I forgot to get out my couplers, but I've got them right down here. So I'm going with these higher end couplers on this printer because of the length, and so these are not your standard spring couplers that you'll find on like your ANET A8, which are back here. I know you can't see that far, and these things are in front of it anyway. But these are some higher end mechanical couplers. I will try to get a good shot. Let's see if the camera can pick up on these. Right here. These are the couplers I'm going with on this printer. Same ones that I'm using actually for the ball screw as well. Obviously a different size, but alright. And these better be the right size, but they are not going on the way they should. How could they not be the right size? It's a very good question. Did someone send me the wrong parts? I'm not sure. Let's see. Hey, let's call you Mr. Robot Gold or Robert Gold. I'm not sure. You can let me know what you want to be referred to as. I'd like to know if higher end stepper motors have a higher resolution than El Cheapo steppers. So the steppers that I've seen have either a 0.09 degree step or a 1.8 degree step. So that is what happened here. It looks like someone sent me a wrong coupler here. And I'm just now noticing this, but that sucks. So let me get close to the camera here again. So this one is the correct one. I'm not going to say right or left because I'm not sure how it's facing you. So this one's the right one. It's got one small hole for the stepper and a larger hole for the actual lead screw. And then this one though seems to be an actual mirror, and so that's not the right one at all. And I'm pretty sure, yeah, this other one in here is just another one for like my ball screw, and that's the wrong size. So okay, what we're gonna do, this is the right one, this one's not. I'm gonna have to get with ZYLtech here and get them to replace it. Hopefully they will. It's been a while since I ordered these. I've been sitting on these parts for a while. But this is the right one. So let's go ahead. What I'll do in just a second, I actually have some of the cheaper ones that I mentioned, the spring ones. And I will go grab one of those. So, if you're unfamiliar with these couplers, these here, the new ones I've got, are way more rigid than these. There's nothing wrong with these. You'll find these on most, low end or inexpensive cheap 3D printers. But so what I'll do is I'll go ahead and pull this one off that I had on another printer, and then we can keep moving. Luckily, I've accumulated a fair amount of spare parts, and so this won't stop us. I hope that answered your question on the resolution of the steppers. Keep in mind also your stepper drivers have something called micro stepping, which I think I'm not misrepresenting it when I say it fakes the steps using the stepper driver. So we can get this on here. Now these are nice. The new ones I'm using are nice. Let me go ahead and take this off the screen so I don't feel like I'm behind something. There we go. Alright, we can go back to the other image if we need it. So, these bottom out in the right place for you, so that's nice. See if this is the right size. That's the wrong size. It's probably the middle one. I think these use the size is this 2.5 hex. Alright, tighten that up. Starting to think this new set here, I think comes with something to help tighten this up. Let me see if I can find what I'm talking about. Yeah, this is what it's for. Okay, yeah. So sometimes these take a little bit more torque because they're round. They don't use the key on the stepper. So I've got this handy part of my new screwdriver set. I can actually get some torque on this screw and tighten it like it should be. Alright, so now that's not coming off. We don't want any slipping on these connectors. And then I just set that down somewhere. Here it is. So this uses the smaller one. Okay, we'll put this one over here. Again, I'll replace this later. I'm using it for now, mainly just so that we get to continue. Now, one thing to keep in mind, if you're using these kind, the spring kind, they don't bottom out the same way. And from what I understand, you need to leave a little gap in the between them because they need to move a little bit. I'm not sure. We'll see. There we go. Okay. So we still got 8 people watching. Again, if you're on social media, please share this stream. Let people know that you're watching. Let's keep moving. So next up, these vertical rods have to be in place before we can put on our top pieces. The actual screws do not. They actually have a hole where we can put the screw in. But the rigid part of this movement system are these rods. And I have made these connectors really tight in the bottom, but I can't really tell where they bottom out. I'm going to give them a little tap to make sure that they are all the way down. I think that is. The only other way I could tell. But I think that's... We'll put the one on the other side and see if it ends up at the same spot. Let's see. Okay, so to answer your question, let's see, 3D Print Viking asked which board I was going to use. So I'm going to initially be using, let's see that, right at the top of these. This is right at the top of these, so yeah, they're both bottomed out the way they should be. I'm initially going to be using, let's see, do I have that? It's still in the old printer. but it is a MKS Gen 1.4, Gen V 1.4. That's the one I'm going to start with because it's what I have. I do think I'm going to want to transition to a Duet Wi-Fi because of the quad beds. I know it's going to have it's already got the code in to handle 4 beds. And so I think I will go with the Duet at some point. All right, these are in place. Now we're going to put on the top pieces, which will hold these vertical rods in place. And there is a hole for that rod here. As I was mentioning, the actual lead screws I can put in later because it's a through hole that goes all the way through. These are probably going to have to be tapped into place though to get. As I mentioned last time, these will only go on top because we can slide all 4 sets of these in place, which is not particularly easy to do, but it just takes a little organizing. Okay, and this is going to be tight. I know it would be. If it's too tight, what I'm going to end up having to do though is I've got a small file here that I can file down that hole a little bit to get it to fit, because I don't want to have to hammer it too much because I worry about breaking these plastic pieces. If these connectors were metal, maybe it'd be different. They'd also slide in without hitting the layers without the problems though. So let's see. This will go because I've already had it in here once, so I know it fits. Looks like I may just have some plastic that is getting in the way. Yeah, the MKS boards, I mean, I have no problems using them. I've used them in 2 different printers already. They're not 32-bit boards. They obviously don't have the horsepower of a 32-bit board. But I don't have any reason to believe they won't print. I know Marlin needs code support still for multiple beds. I have something that is in the way here. Let's see. I think these are just hitting in the wrong. You know how I was saying that these can be a pain trying to line up all 4 sets at the same time? That's what I'm running into. But oh, that's what it is. That one right there is too tight. So we'll loosen that up. Loosen these up. There we go. I'm losing my secondary camera, but I'm not using it, so it's fine. There we go. And we line this up so it's in the hole. And I'm going to have to climb here, I think, a little bit. See if we can tap these in place, or if I'm going to have to file them out a little bit. Hopefully that's pushing down what I want to and not breaking these mounts on the bottom. Again, I made this tight, so it's doing what it's supposed to. I don't want these rods to move at all. There we go. And there we go. Now I know I'm doing some real engineering because I'm having to use a hammer. There we go. Sorry if that's too loud on the stream. I don't think I'm going to be doing too much more of that. So now I'm going to tighten down all 8 of these screws that are holding this in place. And that should make our Z-axis really rigid. And I forgot something already. Oh my goodness. The fun of doing it live. Now that I've done all of the hammering, maybe someone on the stream can catch what I didn't do. Really, really not good. I know how this is going to come apart now. The bottom's going to come out. I'm going to have to leave the top in. That's my guess. That's okay. I didn't put actually on the... there we go. I knew that's the way it was going to come out. That's fine. I'm not real picky. So, it can come off that way. Boy, I did too good of a job. There we go. Okay. So, those will go right back on when we're ready to go. Let me tighten these back down here. Apparently it's only on this side. Those are going to have to be replaced. Okay. So, what I forgot to do. I did not build the X-axis. So, I need to do that first. And I've been looking forward to this part because this actually uses my linear rails, which I have been looking forward to putting together. Trying to figure out the best way to show this to you. Let's see. Maybe something like this. Hopefully it's a decent enough angle. There we go. So hopefully you can still hear me. Yep, looks like the mic is still good. Alright, so let's get this part done. And then we'll put back together those axes. So what we've got here, these are all 3D printed parts. You'll notice I've already put on the lead screw adapters. And what I've got are these, what are these? Yeah, these are LM12UUs. These are the long ball bearings for the 12 millimeter. I'm going to push these in all the way. I was waiting for the stream to show you what these look like. So what I've done is I've created a channel here. This channel will make sure that these go in tight, but don't go in so tight that I can't get them out if I need to later. So these should push in and be firm, but notice the top, I don't know if this thing's going to focus the way I want it to, but there you go. And then we'll do the same thing on this side. These are designed the same way. They should push all the way to the top, but be tight, you know, so they don't fall out. And the weight is going to be on the top part of this anyway. So, all right. How do I want to assemble this? So, we can go ahead, and what I've got here are my linear rails. Got two of these. If I'm not mistaken, these are, see, I had these out the other day. I want to say that these are 16s. And now, so I've gone with what you'll see on the other printers that use just rods, and I've got two on the top and one on the bottom for stability. This will sit on here like this. This is the custom designed carriage that I designed for the Printhead. So that'll go on like that. So I'm just making sure I've got the orientation correct. Notice I've got tie downs here for the tube and for the wiring. So what I've done, I've modeled in where these are going to fit on both sides. And then that middle one, I am putting a belt, at least for now, on the X-axis. So let's go ahead and see if this fits together. That should be tight. And this one should be tight. Obviously, I want these to fit together as tight as they can, because it doesn't help to have really good rails if the assembly of that doesn't hold together and keep it square. We're gonna have to use the floor here a little bit, because it has to go all the way in. Let's see. I think that's almost all the way in. This is really tight. But that's what I want. It shouldn't be easy to come apart. Everything should be squared up. There we go. I think that got it the rest of the way. There we go. So they look like both ends are lined up. It'll square it a little bit more when we put it on the rails, on the rods. So I'm going to go ahead and mount this part to square it up as well. I don't know. Oh, wait. Let's get all this put together first. Switch camera angles. Back to the wide shot. There we go. So, if all of the measurements that I put into that 3D model that I've shown is 100% correct, then all of this is going to fit together perfectly and not require any modification. That should go there. Huh. That doesn't look perfect. So, what is off? Oh, I know what's off. That's better. Okay. That's where those should go, which is looks like it's lining up exactly the way it's supposed to. That makes me feel better. Okay. So, now we can put these back on. And they should go right through the ball bearings. I'm going to line these up. I would have preferred to put this together the way I was starting to put it together to begin with, but in the end it doesn't matter. Let me get my bench out of the way here. Lining these up is more of a challenge than it was when I did it the first time on the live stream. Got lucky the first time apparently. There we go. Come on, don't catch up on anything. I may need to loosen these up again. Where is my screwdriver? There we go. Okay. And once we get it low enough, it should want to go into that hole on the bottom. Then it actually goes straight down to where we want it to. Beautiful. Let's see. Chat is pretty dead tonight, so if you are still there, please say something. Let me know I'm still streaming. And I would appreciate it. I'm going to tighten these up a little bit. I'm not going to tighten them all up because I want to make sure I get the other side on first. Let's see. All right, let's put on the other side. That goes exactly where it's supposed to. Line this up. There we go. Man, that is lining up perfectly. Hopefully I don't jinx it too much by talking about it. Alright. Okay, that's on the bottom. And that's on the bottom. Thank you, 3D Print Viking. Still got 8 people watching. So all of you that are in the chat, or excuse me, watching but aren't in the chat, I still appreciate you coming by. Let me go ahead and now I'm going to, before I tighten down these too much, I'm actually going to go ahead and get these put in, because it will line up these top ones where I want them. I don't want to do too much on the sides without making sure that the top ones are where they should be. And last time I did that, I had a tie strap. That's what I'm going to use this time as well, to get these nuts where they need to be. I just put them in the slot, and then I push these down to where I can see it in the hole. This is a more complicated top bracket than you normally see, because I'm actually using the top bracket to square everything off to provide some more stability to all these components that are coming together in this area. A little bit more complicated on the assembly, and things actually have to be more square this way, which I really like. As you can see, it's not hard to do. It just requires a little thinking about how are you going to assemble it. So that's square now. I'm not tightening them completely. I'm just kind of going around to make sure that all of these components end up tight at the same time and it's square like it's supposed to be. With this many screws in this corner, everything should line up once you get things good and tight. Alright, so that should mean that this one's square. And this is very, very tight down in the corner. Let me grab that. I was really liking the torque I was getting using that extra piece, so I may have to find it in a minute. You got so many pieces and components out on the table doing prep work, it's easy to lose little connectors and such. Hope you guys are enjoying this. I enjoy the live streams. I know I've heard from others that doing a live stream kind of scares them because, you know, they don't know what's going to happen, and as you can hear with me talking, you got to fill up some airtime. But I think it's a lot of fun to just do the hangout. Let's see. Some more of these, and then we'll do the other side. How we're doing time-wise? Okay, we're not even through the first hour yet. We've got most of this assembled, so we're doing pretty good. No major problems. Like I said, I think the only thing I've found is these bottom brackets need a little bit of work. But yeah, this is the same way. I know you're looking at the back of my head now. Sorry about that. Cannot be helped. I want to make sure you guys see what's going on, so that's why I flipped the printer around for this build. Let's see, did I get it? Yep, first time. wasn't sure it was trying to lay down on me. And I find I have to use these plastic straps for this because otherwise otherwise something's always magnetic and it just wants to hold on to them. I'll look down the rail, see if it's okay. That's doing what it's supposed to. And now that's gone. Let's see. So that's a little tight. That's a little tight. Let's go ahead and get these while I'm around here. Again, I do 2 sets of tightening on these. I'll make sure they're in place first. This should be level, so I'm actually going to loosen them a little bit more and see if I can level this off a little bit like it was supposed to be to begin with. Okay, that's actually square. So besides the these live streams that I'm doing, building this printer, I've got some other kind of more mainstream stuff to show you coming up soon. I'm going to do an Ender 5 easy upgrade video that shows just some of the most the easier things that you can do to upgrade an Ender 5. Something that's not necessarily changing the way that it works or making major modifications to the machine, but things like changing out your nozzles, adding a glass bed, and upgrading the extruder with a metal extruder. So if you have an Ender 5, if you're interested in the Ender 5, and that's how a lot of people came into my channel to begin with, I'm going to keep up those kind of reviews or those kind of stories. All right, so that's rigid. That's not moving. And this, if all goes well, should move freely. And it does. Nothing is scraping. I've got just a little bit of space between the two. So that's exactly the way it's supposed to work. I'm impressed with the CAD. It turned out exactly right. So next up, let's actually put in our lead screw. So with these lead screw, I've got the these on the bottom, which are the, I think, anti-backlash. If you missed it last time or if you didn't see it this time, I've actually got a ball bearing in here, and the ball bearing's an 8mm ball bearing. It's a 608. This is an 8mm lead screw. Oh, this is the wrong one. This is my short one. I wonder how I was about to get worried. Like, I measured these. All right, so this one goes here. 8mm, like I said, matches the ball bearing, so it will roll perfectly there. And then this should go, hopefully. These came together. I know they're the right size. This will go into here. Okay, but like I said, I've got these anti-backlash nuts, which I'm not really concerned with the backlash because these don't move that fast. I use them because I find without them, these rails have a tendency to rattle a little bit. And so for me, this is a noise reduction feature. I had that on my A8 where I just added them to keep it from rattling. So these key in together, and then you can find out where they, there we go. Again, it just keeps it tight. It keeps that assembly tight there. And then I need to take this down into here. A little tighter than I expected. Maybe because I don't have the other side in yet. So let me, before I put it into that coupler. Let's try to get both in. Let's see. Ender 5 upgrade video. That's a good question. I would actually have it really soon, but I actually still have to get the glass bed. Let me see. I don't have a time for you. Maybe the end of next week. My biggest problem is that I have too many projects going on at once and I don't know which order they get done in. So beyond that, I also have a video for the Ender 5 talking about the cantilevered bed and whether it's really a problem. Because the biggest complaint I have about the Ender 5 in terms of what I hear online is people complaining that it's a cantilevered bed and that it must warp when it gets too heavy or that over time it's going to sag. And so I've got a little video that I've been working on about that. The only problem with that video is it's been evolving, so I've changed it twice already because I want to make sure that I cover as many people's concerns as possible and not miss the real issue, because I know if I'm not thorough, I'll be called out on it, as I should be. So that one's changed a couple of times. And then I have some fun projects. I am working on a Avengers Endgame project, but that one's even further from being done. The prints are done, and if you look around in the background you can actually see them. I left them in frame. This is a pain to get this lined up. Let's see. May have to move some things around so I can get a good grip on this. Alright, let me back it out a little bit. The clips here are not going in exactly like they're supposed to. And if I don't get them clipped in correctly, then it won't work. That may be it. Let me see if that's in the right place. There we go. Alright, got that one now. See if we can get that in the coupler. Need to make sure that these couplers are actually... So yeah, the upgrade video is coming. It'll be in the next week or two, depending on exactly when I get my glass. Because I don't worry about, that one's not going to take long to film or edit. It's stuff I've done before on plenty of other printers. But I know a lot of people, the Ender 5 may be their first printer. They may not have experience with any kind of upgrade. I know we were all there at one point. And so I'm just going to do kind of a basic video about how to do that kind of upgrade. How to upgrade the bed, how to attach a new hot end when you've never done that kind of thing before, and how to upgrade the extruder. Is it really a big deal? Of course the answer is no, it's not a big deal. So again, I'm almost got these attached. Sorry, you're looking at the back of my head rather than the work I'm doing. Let's see if I can move back around now. Need to loosen this one up, I think. This one seems to have a little bit of a warp to it. I think that maybe what I'm doing here is a slightly warped lead screw. It's a long one. The other side may be better than this one. Let me take a look. Yeah, it's got a kind of a curve to it. If it's just a minor curve, we can usually bend it back out. I don't know how minor this one is though. Let me take a look. Which way is it bent? And where is it bent? So we're doing a little bit of, I know my bed's pretty flat. So there's the bend. Yeah, I can see it. It's in this area. Needs to go back a little bit this way. So I'm just bending it back a little bit over my knee. Again, the lead screw is not what keeps these straight. That's what the rods are for. The lead screw are just for driving it. And it's peaking right here. What I'm doing is just putting up my knee, taking it back over it just a little bit until I get it straight. Should be doable. As long as it's not a damage to the lead screw. These are long ones, like I said. Ball screws are sometimes better for this because they're thicker. I knew I was kind of taking a risk using an 8mm. I figured once I got it installed, it wouldn't be a problem. So let's take a look again. That's a lot better. So just showing you, if you get one that's kind of warped, it's really not that big of a deal to fix it. I think some people immediately want to send these things back, but we'll see how it works. Maybe I'm wrong. Maybe even after I do this, it doesn't ever work quite the way I want it to. But if that's the case, I just need to change my system. Let's see if that works. I'll find out. If this won't move smoothly, show me the same problems I was just having. I haven't looked at the chat for a few minutes because I've been in front of the printer, so I will check on that in a minute. That looks a lot straighter this time. So I think that took care of that issue. That bottomed out now. See if we can tighten it. Let's take a look. Let's see. Are you installing a Pet's Fang or Bullseye on it? 3D Print Viking, I think you're going to have to let me know what you're talking about. What is a Pet's Fang or Bullseye? Is that just for decoration, or is that an actual functional part that you're talking about that I'm not familiar with? E5 beta problem. I have the same cantilever set up on my Flash Forge, which cranks out really nice prints. E5 supports. Yeah, so, I mean, not to give away too much of what I'm finding out. My personal belief is that the cantilever is not a problem. That due to the way that the Ender 5 is actually designed, that it has more than enough support for any normal print that you're going to put on that bed. I mean, you have to really think about how much weight's actually ever going to be on it, and whether that actually creates a deflection. So I've created a fairly large print. Again, I'll give you another little teaser here. It's not assembled yet, but printed it as large as that printer would print, and I'll let you know what my findings are. But I'll tell you, my personal belief is no, it's not a problem. I think in modern printers today, people have kind of idealized what it should look like and what features it should have, and they pick out any mechanical problem that the printers could have and kind of go, hey, what about this, what about this, what about this? And I don't think that all of those are necessarily problems. There we go. Look, everything lined up. What can I say? I'm proud of that. So now we have these. Again, nothing has been lubricated. I have, once everything has been assembled, I've got this white lithium grease from DuPont that I'm going to be using on all of the movements. Let me get me a sip of drink here. So here we go. It looks like my Z-axis is good. It's not falling, but it can be pushed if I push hard enough. So I think it's a good movement. I won't know until I actually hook up motors to it and get them moving in sync. But let's go with this. Next up, again, this is my transition here. So this is my custom design printhead. This is based upon one that I was using on another printer I designed. I know this is not completely in focus. It's a webcam and only wants to have a very small focus. But see here, this is my ZYLtech, an authentic ZYLtech with a V6. And I plan on putting the V6 in here like this. Get this out. I actually tightened this earlier, and so it doesn't want to come out now. Of course. So again, here it is. This fits in here. I'll tighten this down a little bit so I get it oriented correctly. And so let's put it in this way. And that's going to go right like here. And you'll notice that I do have, oh, upside down. So it goes like this. 40 millimeter fan goes here. 2 blower fans go here, blow this way. This is designed to be a dual cooling because I found when I print things that have curves on both sides of the model, the curves on one side do not look as good as the curves on the other side. So, what material? This is PLA, but I use a high temp PLA because it's more rigid than just standard like PLA that, you know, cheap $15 PLA. This is high temp stuff. It is about print these at 235. And since you ask, let me point out, I want to give a shout out to Coax, who has been kind enough to send over some filament for me to try out. They are a North American company, and I've been looking for a domestic supplier. This is some filament. Oh, there, I forgot I was on this camera. Beautiful filament. I love this color. And again, let me show you their logo. This is Coax. Boom. There we go. And they're at coaxllc.com. And I'm going to try out their filament. I haven't printed with it yet, but this is, again, another high temp PLA. I think it's going to be good and rigid for mechanical parts. I don't want to tout the previous supplier I was using because I'm not using them anymore. They've been awful in terms of customer service. They've stopped answering emails. I've got about $100 order in with them right now that I'm trying to get them to fulfill. And they are not making it easy. So I'm not going to talk about the supplier I was using. But look for PLA that prints in the 220 to 235 range. Like I said, from personal experience, I find that it prints a lot. It produces a harder plastic than the usual stuff. I'm sorry, I'm right in front of this camera right here, but I'm looking for a Phillips screwdriver. I'm not sure this set has the Phillips screwdriver I need, so let me just switch over to one of these that's sitting here. All right. So let me go back to the wide shot because I'm actually on the front of the printer for this. There we go. Again, I'm going to try out Coax. I will let everyone know how it does. I don't plan on doing just a strict filament review because I don't think people particularly spend a lot of time in filament reviews. I think it's much better to show actually printing something with filament rather than just, you know, a bunch of test prints. I like to find things that are functional. So, all right, so let's mount these. These are M3 screws. They are really short M3 screws, though. I think I need my blue box. Let me see the washers. Yep. So I got a bunch of washers I'm going to need for these. Because this thing takes 12 total screws to get going. That's 6, 7, 8, 9, 10, and 12. All right. What's this one I already had in here? So these should just M3s. I think I'm using like M3.5s in here right now to make these fit. I had some M3.8s, but even those were too long enough. Or excuse me, too long. So, and let me see. Maybe if I can get zoomed in here, you can see exactly what's going on. I haven't wanted to do. Ooh, yeah. See, that's why I didn't want to do too much camera work. I'm gonna have you looking at the floor. But that should be a little bit better, I hope. On the hole. There it is. What I'm trying to do before I put in too many of these screws into different ones, I'm lining up all of my rails. Yep, they're all lined up. So I have to say, I can't give Fusion 360 enough credit for this project, because thanks to them, I took care of a lot of issues that would have come up in construction. Fusion 360 saved me a lot of money by letting me know that certain parts weren't going to work because they weren't going to fit together. They've saved me a lot of print time because they were allowed me to model all of these based upon models of these parts rather than having to wait till I had the physical parts in hand. So I can't say enough good things about pre-modeling your large projects. Obviously, I've been working months on this because of doing the modeling and getting the parts in and all that good stuff, but it will save you time and money in the long run. I will pop that back up on the screen before I'm done, just so you can see what the model looked like compared to what the actual physical machine is looking like. I'll go back to the chat in a minute. I know I saw something pop up on the screen here, but I'm trying to reach the goal of getting most of the mechanical components assembled in this stream. I've only got 2 hours total. And if you're new to my channel, this is Kersey Fabrications. I am just getting started. Got the last live stream I was able to pass 200 subscribers. That was a nice milestone. And I have been, I guess, going just a little bit. I had a channel on YouTube for, I guess, about 6 months, but I'd only put up one video and then maybe another 1 or 2 just here and there. I've been trying to produce regularly in the past month, and it's really done well, particularly with the Ender 5 review. Gotten a lot of positive feedback in that review, particularly once I got the, what I was told, annoying background music out of there. I always like background music in videos, so that was a personal preference, but I got way more negative feedback on that than positive feedback, so at least I know where the general audience stands on it. Feel free to comment on what your thoughts are. I'm keeping, obviously, background music when I've got interludes or time lapses and stuff like that, where there would be no audio otherwise, but while I'm talking, I'm getting rid of the background music. Apparently it was distracting. I don't know if it was the music in general or the fact that people didn't like the taste of it, or I don't know, the style of the music. My taste in music, I should say. Alright, let's see how this works. think this needs lubricating. Yeah, I think the more I play with it, the better it's rolling. So I think this is a lubrication issue, doesn't appear to be binding. So we'll get some lube on here, and actually what I may end up doing is loosening it up here on the ends a little bit. I've got a little bit of play in this mount on purpose, obviously. So let's do this. Let's see if I can get it rolling a little bit smoother. I found this from the last printer I built, which was just a prototype. If you loosen it all up and then push it to the extremes, and tighten up the one closest to that extreme. I need to stop that so it doesn't annoy anyone. And that's a good way to tighten it up and prevent binding, rather than tightening it in the center. There we go. I'll tighten this one down here. There we go. This one down here. Okay. Is that all of them? Nope. Okay. Yeah, that's better. All right. So there is the x-axis. Got the z, got the y. All of our axes are put together, running the way they're supposed to. I'm going to move this back over here. I'm going to move this over here for that assembly. Okay, let's go back to the chat for a minute. And let's see. Good evening, everybody. How's the build been going? Hey, Wiles3D. I appreciate you joining me. Build's going good. As you can see, I actually have all three axes assembled at this point. Yeah, hey Pygar, good to see you again. And how do you such a large flatbed? How do I what? Let me answer that in a couple of ways. I needed a large flatbed for printing props and armor. And I got this large flatbed by designing the CAD and then going to a local water jet cutter, asking for the certain type of aluminum, excuse me, and getting him to actually water jet cut this to my exact specs. So if this printer really pans out and I'm happy with it and I can get a group going, then I could possibly do a group buy of these components and get everyone one of these beds. So what do I want to do next? Let's see. I'm going to work down here. So I'll go ahead and unhook this for now so that I am working. What time is it? It's 9:20. Still got a little bit of time. That's good. So the way this works, you can see, this is the V6 extruder with the auto leveler. I went with the auto leveler on this printer because it's such a large bed. This is actually pretty easy to assemble. You'll notice I've actually designed this for these grooves. I've got a couple of screws in here. These are M3s. And right here, this can be pressure fit in place. And then I get my M3 size nut, and you can strap down. Oh, you know what I just realized. So, okay, this, actually the way I tighten this is I designed this to hold the M3 nuts actually in the frame so that it can be tightened down all the way. So if you don't embed nuts into components, they'll tighten down, but they won't tighten down all the way, because at some point what you're going to do is just start either stripping it out or busting up some plastic. So I assembled this, or I designed it to actually embed the, let me see if I can get it to where you can see it. So I'm embedding the nuts here in the side. And I know this fits because I've done it before. It just requires a little bit of pressure to get them in the right place and get them all the way in, hopefully. If I get that in the right place. Hopefully I give myself enough room to get it all the way in. I'm trying not to get in the way of you guys watching what I'm doing. You get a little bit closer. So I'm going to be working on this for a minute. There we go. Sorry about the wiggle. Pull this back out for a minute. I'm going to have to get in front of it here because I cannot see what I'm doing. Better go all the way in. Otherwise, I'm not going to be able to fully show you what this is supposed to look like. So, let's try to get these all the way in place with it. This one's too little. I'm going to bend that one. Let's grab the next size up. So this is why some people don't like to embed the nuts, because getting them in place is kind of a pain. If you don't get them in place, the whole print is kind of a waste. I'm going to try. Well, we'll see. I'm not sure. This, like I said, this worked on another print that was almost exactly the same. But let's see if it'll work now. You know, while most of this is the first time I've done this full assembly, I do try to be a little bit more careful with my prints to make sure that that's not a failure point in these videos. See if we can grab it. I think that grabbed. It'll tighten in place once it grabs all the way down. Yep, that one definitely grabbed, because that is tight now. And if this one's going to be nice to me too. All right, there we go. So that is in place. These will get wired up later when I start doing the electronics. Okay. And a fan goes on the front. I can show you. I'm pretty sure I've got the fan here. Yeah, here it is. So this is a custom fan grill I printed just to keep fingers out of it, and that will go right on the front like that. This is an Octura fan, runs really quiet. More than enough cooling for this, and hoses. There we go. Okay. So, any questions before we keep going along here? Let's back it up. I'm not going to do all of that assembly yet, because if so, I'll probably have to pull it back apart. So, there we go. Okay. So, what's next? So, one thing, I've got my, so where the extruder is going to go. Got an extruder motor here. Yep. Which can attach to here. Extruder will probably go either on one side or on the top. I'm not 100% sure where I'm going to put it. I think I'd like it centered, but only if the wires reach. I don't want to have to do a lot of extra wiring. Let me go ahead and show you this part. So this right here is the end stop for the x-axis. I'm going to actually switch to the close shot here so that you can see what I'm talking about. And I will have that ready for you in just 1 second. Yeah, got to get to where you can focus on it. Now I'll do a transition. All right. So, doesn't really want to focus on this, but notice I have built, this thing has big through holes on the bottom. Okay. So what I've done is I've built this into here to not need posts or anything else. These actually go straight onto here. And we're going to screw these on here. And then we can test that end stop just to see if it clicks. If it clicks, we know that it's a good end stop. Getting rid of some of the garbage. I've got some self-tapping screws here. It's probably the only thing that's not metric on here because these are ones I just had. These are number 228 thread, 5/16 of an inch. And let's grab that Phillips head screwdriver again. And I've built the holes in here. And these just go straight in. This is all modeled really well, I have to say. I'm very happy with how well my models overall have done for this project. And like I said, if all goes well, this goes straight into here. That one actually may need something else. The other one's tight. Alright. And if this is good, it will click into place. I think I'm off here. I think it's not square anymore. Let me see. Let me get this square a little bit, and if I stop leaning on it, then it'll run a little smoother. So I'm just measuring here. I've got 9.5 centimeters on this one. I've got, yeah, that's too low. That's the problem. That's 9.5 centimeters. That should still smooth. There we go. And that's not a good one. Oh, you know what? So it looks like I may have a little bit of a problem. Do I have those fans still connected? I thought I brought them up here. But I don't think that fan's going to go up high enough to make a difference in my model that's clicked. So what I'm probably going to have to do is modify this a little bit and put something new here so that it'll actually click when it stops. Not a big deal. It's a simple change to the model, and I'll just have to reprint it. Okay. Yeah, because it is not touching anything. Curious to see what it looked like on my model. Did I miss that? Let's put the screenshot up here. We'll take a look at it real quick. On my model, I really thought that it would be fine. Yeah, see? Oh, maybe my model shows it correct. Maybe I was just looking at it wrong. These angles are kind of hard sometimes. So, yeah, I guess that it doesn't really hit it like I thought it would. So I'll go in and I'll modify that carriage to hit that end stop correctly. Like I said, it's a simple, I mean, this carriage doesn't take that long to print. That's easy to fix at a later time. All right. So, sorry. So, next part of this is the actual belts that are going to be on here. So, this is the end that actually holds the X belt. It actually tightens it as well. So these are M5. I think these are M5. Let's see, are these M4s or M5s? These are M5s. Okay, these are M5 nuts. And these pressure fit into here. And I just need to get a pair of pliers to do that correctly. If not, this is a vise issue, and I'll go in and push it in with my vise, which I obviously don't have on the table here with me. But not a problem. Okay. Let's give me. I'm going to take a small intermission here since I skipped the one at the halfway point, and I will be right back. Alright, I'm back. Again, I just went out to my garage, used the vise to push these in. I always recommend the vise because it puts good even pressure on them. So I've made this piece where this actually fits directly into the end of the piece down here. You see this hole here. And then I can attach my gear, and this will roll freely because I've given it enough room. So if you don't over tighten it, this still spins freely. The nut's in there, screws in there tight enough to not to spin free. And like I said, this goes straight in here. If I put 2 M5 screws, I'm gonna pick 2 the same length. Let me see what I got. Okay. Now if I take 2 M5 screws and put them in these ends, the reason that these are in the drawer is they don't want to go all the way through. Oh, that one's good. And then this one goes in here. I got kind of a messed up nut, so let's grab this and we'll get it in here. What is wrong with this nut? Picked the wrong nut for this. Okay, I'm going to choose a different nut because this one is damaged. So that one's going in the garbage so it doesn't bother me again. Grab another M5 nut out of here. And so I'd already used the vise. That hole had opened up pretty good. And now that goes in there. And so what I can do is use these two to tighten this belt. I'll go in there, and then it can be tightened down. Okay. So the belt design on this is pretty simple. Let me grab the belt. So what I've got here is a genuine Gates belt. Gates is a manufacturer. If you notice these, hopefully you can read that. I doubt it on this webcam. I need to get a better close-up camera because that doesn't want to focus at all. Okay, so these are genuine Gates belts. These are, I believe, carbon fiber belts. Maybe not carbon fiber, but fiberglass belts. And these are super nice belts. So I'm going to take this around here. This will I use zip ties here and here to hold this on. And then I take it around. I can show you how to do it because it's not a big deal if I've got to pull it off. That was all of my filament. Let me see if I can find the right size I like to do this with. So, I got some snips. So, I've seen a lot of fancier ones than these, but after using some of the fancy ones you can print, I find that these work the best. And all these, I've designed these posts. They screw into my my carriage, and then I put an M3 screw through the middle, so I make sure that they don't break and that they're rigid. So when you're attaching a belt to a printer, make sure that you pay attention to the orientation, because this is going to have to go around the idler and go around my stepper motor. So I'm going to take this around here. See if I can get a slightly better angle on this for you. There we go. Okay, so These need to be up on this side. Maybe I actually want to thread the whole thing around. So let's do that. I'm going to take this one, now that this is in place. I'm going to pull this through here. Take it around the idler, back through. Give myself enough belt to get back through. Okay, at this point, it's on the idler and it should run smoothly. I'm going to take this. I've got a lot of belt here, so there shouldn't be any problem. I actually got 5 meters of belt, just in case I needed it on the other axis as well. Let's see, that's the... Here's this one. Okay. I'm going to take it through this side. And as you can see here, this is the stepper motor. And I know this is terribly out of focus. I apologize. That's what I've got to work with. And I'm going to take it around the top of the stepper, around the bottom of the stepper, and then back through the mount. And that will pull us back through here. So now this should fit right here. There's a small groove there for that belt. And then this will go around here. And let's see if this is not something I modeled. So we'll see how it goes. Get no chat in the while. Excuse me, no chat for a while. Please let me know if everything's coming through. If everyone's still there. We will take this around. And again, the grooves of the belt will hold itself in place. And as I mentioned, this is one of the best systems for doing this that I found. I've played with some of the 3D printed ones, and a lot of times those have broken off. That doesn't do anyone any good. Let me scoot this down a little bit and give myself a little room to pull this off later if I need to. And then I tighten it down. Then you take the snips, so they're good and tight, and cut it off. Do the same thing here. Now that the first one's in place, we don't need it attached to do it. Man, you have hung out way longer than I think I would be, so I really appreciate you staying up so late. I assume it's Saturday night for you. I guess I should say Sunday morning for you at this point. But I appreciate you hanging out, Viking. You guys, this is 3D Print Viking. If you're not familiar with him, go check him out on Instagram. He's got a nice Instagram page where he puts the stuff that he has been working on. Okay, again, I'm going to make sure these are loose enough on my ends. And if I pull this tight, I'm going to have a good starting place to tighten it down. But I also want to be able to pull these off later if I need to, because I think I've already mentioned I'm going to have to do a little bit of maintenance. So let's go with this. I think this is a good place, because it'll still come off later if I need to. Hey Pygar, sorry I missed yours. Appreciate you hanging out too. So I have not seen any difference in the chat numbers. In fact, I'd say I've had less people in the chat tonight than I've had in either of the other two streams. So for some of you that this is not the best time period, I think it's safe to say that unless something changes, I'll probably stay out of this time slot in the future. Doesn't seem to do me any better. It doesn't seem to be any better for people. I thought it would be Saturday night, but no such luck. So, again, Viking, appreciate you hanging out. I will hopefully have a better time slot for you. I actually kind of like the Sunday time slot I did last week.
Wasn't too bad before dinner. Wasn't so late for people. Again, these are in place. I'm double check it before I cut the belt. Let's see, before I cut that, let's see if it tightens. Looks like it. Looks like that's not going to be any problem. What I'm doing like is just tightening. I hand tighten these at the moment, and until they get too tight, actually use it a little bit more. I'm not worried about these slipping once I get them tight. There we go. Actually, I'm curious if I need to move these down a little bit or if they're going to scrape. But it does tighten here. This is pretty good. I've probably gone one more tighter. But that's not going to change where I cut it, really. There we go. That's good. These might have to come down a notch, but that's just part of the design process. Let's go and cut this off here. I'm going to give myself some extra room though. There we go. So that belt has been cut to length. And it should still slide. Actually slides even better than it did before. I do have some scraping with this belt. Trying to figure out the best way to fix it. Looks like I may just have to move these posts here and here down a little bit. I think the top one is right where it should be. But I'll play with it, because if this is moving at a lot of high speed and that's scraping against each other, it's going to be a problem. That's true. That's true, Viking. So, what is left for this one? So, I have about 10 more minutes, and I think I know what I want to do for the last one, because a lot of the other stuff I need to do is electronics or electronics related. I've got a LCD display that I need to mount, but that's not too interesting. I really thought the mechanical portions of this was the most interesting part of the build, showing how all of these different movement components go together. And the ball screw moves the Y direction, belts in the X, and these screws on the Z. So let's take a look. I am going to go back to the wide shot for this part. So I want to show you how I was going to do the beds, and that'll probably be the last thing for this stream. And then the rest will go together off camera so that I get this done and actually printing one of these days. So, but where did I put beds? I know where I put them. Put them back in the box. So, here are the beds. Again, if you're not familiar with this, I think most of the guys that are here are familiar with this at this point. But these are 200 by 300 beds. These are, as you can see, these are MK2As. These will run off of 24 volt or 12 volt. Haven't put on any of the electronics yet. Make sure I'm not scratching them up. Yeah, most of these still look good. I also ordered these from ZYLtech. These are really thick ones. These are 3mm. I actually went looking for the 3mm ones because I didn't want wimpy beds if I'm going to be putting a lot of heat into them. And I'm also going to be covering them in these. This is foam insulation. The bottom side is aluminum, and the top side is a self-adhesive. You can see that there. And once I get all of this up and working the way I want it to, I will come back and put these underneath the beds for insulation, because I don't want to lose too much heat, waste energy on heating this much bed space without them. Let's show you how I'm going to actually assemble this. Let's take this one. Let me check this. I've got a little mark on the bottom of this one. Should be fine. This looks like some of the paint has come off. So, what I've got is, I actually pulled these aside already, and this ball. So these are 2.5 millimeter standoffs. Why 2.5 millimeter? Because that's the only size that will actually fit in these small spaces where they have to go next to each other. So I think I can show this to you or demonstrate. Can you see that all right? It's not great. Let's see. I'm going to have to go to the close shot again. Okay. So, moving my phone out of the way. There, again, all of those. Some of this wants to stick. So what we're going to do is get a better shot of what I'm actually working on. Alright, this is the fun part of live streaming. Okay, so I've got this 2.5 millimeter screw. All of these were water jet cut to actually be the right size. I'm going to put that on top of there. Now the space here, kind of undetermined. I'd rather them be shorter than longer, but for now I'm going with the longer ones. These are, let's see, these are 20 millimeter, 2 centimeter standoffs. Come over here. Forget I can't push this bed. I'm not used to that. Used to belts, you can just push everything out of the way. Get out of my way. Hopefully these don't interfere with that movement. There's a little bit of room there. I guess I'll find out. There you go. Let's see if it interferes since I mentioned it. Nope. There is just a hair between them, which is good enough for me. Because this, you can't see what I'm pointing at. The ball screw is keeping the center of this bed from drooping at all. Okay. Now that you see what I'm doing, I will go back to a cleaner live shot. And go ahead and get this one aside. I just wanted to assemble these because I haven't actually tried this part yet. I wanted to see what they look like. Obviously would be one of those things that would have been easier to do before I assembled the larger bed, but I wasn't ready for that part yet. There we go. And then this, so got to watch the orientation. This is where the wires will be coming out, so I actually want those coming out the back of the printer, not the front. I actually do have holes for strain relief that I'm going to use. These fit right on top of here. I'll tell you what, again, I'm loving the good CAD work. In terms of it actually, the CAD working out the way you expect it to, it being correct enough for even a consumer like myself, end user, to CAD these parts. Not have to spend a lot of money on prototypes that are going to fail. Oh, you know one thing I'm doing right now? So these this is actually the print bed, which means that what I've got is countersunk screws that I'm actually going to be using on top. Because the top bed has to be perfectly flat, I do plan on putting a piece of glass on top, but even with the glass, it has to be a flat bed. Otherwise, the glass wouldn't make good. Yeah, there we go. The glass wouldn't make good surface contact with the metal. That wouldn't be any good. So these I plan on countersinking. So I actually have a countersink that I'm going to strip out this aluminum with a little bit. And there we go. And for the sake of showing what one of these joints is going to look like, I'm actually going to put one more of these on, and then we're going to call it quits for tonight. I think I've covered most of the mechanical assembly of this printer in the 3 live streams. What I'd like to do, as time permits, is to go back to all 3 of these live streams, put them together into one sort of condensed video, so that people that either have missed parts of it or want to go back and rewatch the high points, and not have to watch all the parts that didn't turn out exactly as I expected, can do that. A little bit more interesting. I'm just tightening these up. These are a little harder to tighten when they're really close together. Yeah, I think it's a good idea too. Some people have missed parts of it. I've had a couple of people that have been in for 1 or 2 streams but haven't made it through all of them because of time commitments. This is a hard part. My arms and hands are not the skinniest. And getting in here underneath this bed is not easy. There we go. Then we'll get a good shot of what these beds look like together. I actually think I have a socket that would work on this, but I can't get in there because it's too tight. Last one. A question from 3D Print Viking was, what am I using to edit my videos? I am using Power Director, which is a cheap alternative to, or an inexpensive alternative to, using Adobe software, because I did not want to spend the money for Adobe software. So it was something you get for under $100 for a non-monthly subscription piece of software, which is what so many of these are going to now, trying to get your money every month, and that was not something I wanted to sign up for. So, and oh yeah, there it is. It's not the best software. There are things that I've tried to do with it that either I haven't been able to do, or it's not super intuitive. I figured it out or found a way around it, but it's not the most intuitive piece of software. Recently, Angus from Maker's Muse was asking about that on Twitter because he wanted to drop Premiere because it was getting too expensive. And so people gave him some ideas. So if you check out Maker's Muse Twitter account, he's recently asked about that. I think there are some really good ideas on there. There is a free solution, completely free solution. I don't know if it was available when I was looking, I was unaware of it. I don't remember what it was called off the top of my head. I did take a look at it. I'm going to download it and try it. I think for now I'm going to have to stick with Power Director because otherwise the look and feel of some of my videos would change. But at the point where I'm ready to sort of revamp some of the design ideas, that's when I would switch editors. So this fit together perfectly. Let me switch over and give you a good live shot, because this is what I was really hoping for when I was looking at the multi-bed design. This is a really clean seam and it is very smooth. The transition here, you can feel it, but it and it's super rigid. I mean, the whole bed is very, very rigid now that I've got 2 layers of aluminum together here. So these beds, again, the beds, the extrusions, the ball screw, and the Y-axis rails, which you can see under here, were all from ZYLtech. I purchased them myself. This is not, they have not donated any of these components. So, but I wanted to send a shout out to them because this made this, they made this so much more affordable. Because they had some of the best prices that I could get domestically, not having to order these from Chinese shops and wait a month for them to get here, which is you know, how we have to do some of these parts sometimes. Unfortunately, this large, these 700 millimeter linear rails I did get from a Chinese shop. I'll be happy to share it. I've been happy with them. Haven't used them very long yet, obviously, so I can't really give them a too high of an endorsement, but they seem to work. They're very rigid. I was one of the things I was concerned about with linear rails was how are they going to be too flexible? Given the long span, are they going to move too much versus rods? And they're definitely harder than the hardened rods that I've got here. So I'm happy with them. So let me see, any more questions for tonight? Again, thanks 3D Print Viking, Pygar, Mr. Robert Gold, and Wiles 3D. Let's see, hopefully I haven't missed anyone that's been in the chat tonight. VJB and Robert Reynolds, who showed up early. So thanks again for watching. This has been my last live stream for this project, and stay tuned to a condensed form of these 3 videos and the other projects I mentioned in this live stream. Thanks for watching, and see you later on Kersey Fabrications.